Hey everyone, and welcome back to the channel. Get ready to have your mind officially blown, because today we're diving headfirst into a world where everything you thought you knew is about to get a serious shakeup. We're talking about those wild, unbelievable facts that sound like pure fiction but are 100% true. Did you know that the apex predators of our oceans, sharks, have been cruising the deep longer than there's been a single tree on land? Think about that for a second. The mighty oak, the towering redwood, they're all relative newcomers compared to these ancient mariners. And speaking of things that defy expectation, prepare for a fruit-fueled revelation. Those yellow, curved delights we call bananas, they're technically berries. Yes, you heard that right. But here's the kicker. Strawberries, those iconic red berries we all love, are not. Confused yet? Good, because we're just getting started. We'll also explore the almost magical science behind starting a fire with something as seemingly contradictory as ice. It sounds like a survivalist tall tale, but it's a real-world technique that will leave you absolutely stunned. So, if you're ready to question your reality, expand your knowledge, and probably win a few trivia nights, then hit that like button, subscribe if you haven't already, and let's unravel these incredible natural paradoxes together. Number 1. Sharks are older than trees. Today, we are kicking things off with a mind-bending truth that flips our understanding of Earth's timeline on its head. We often picture ancient landscapes as vast, sprawling forests, right? Towering trees, roots digging deep, stretching towards the sun. It's a classic image of primeval Earth. But what if I told you that long before the first tree ever cast a shadow, a creature we know very well was already navigating the planet's waters, a silent, powerful hunter evolving in an ocean without any leafy counterparts on land? It sounds like a riddle, doesn't it? What's older than a tree, but still alive today? The answer, astonishingly, is the shark. Yes, the very same sharks that glide through our oceans today, from the mighty great white to the elusive Greenland shark, belong to a lineage that predates almost everything we associate with terrestrial life. Let's talk timelines. When did the first trees appear? The earliest true trees, with their woody stems and branching structures, emerge around 385 million years ago during the Devonian period. These were primitive compared to what we see today, but they marked the beginning of vast forests that would eventually colonize continents. Now let's look at sharks. Fossil evidence reveals that shark-like fish, often called placoderms or early cartilaginous fish, were patrolling the seas a staggering 450 million years ago in the late Ordovician period. That's a difference of about 65 million years. Imagine that for millions of years, the dominant large life forms on Earth were aquatic, with sharks or their very early ancestors as top predators, while the land remained largely barren, covered only by simple, non-vascular plants, mosses, and fungi. No towering trees, no sprawling root systems, just an empty, rocky expanse. The first sharks were, of course, different from modern sharks. They've evolved, adapted, and diversified over hundreds of millions of years. But the fundamental body plan, a cartilaginous skeleton, multiple gill slits, and rows of replaceable teeth, has remained remarkably consistent, proving to be an incredibly successful evolutionary design. They've survived multiple mass extinctions, including the Permian-Triassic extinction event, which wiped out 90% of all marine species and 70% of terrestrial vertebrate species. While entire forests burned or withered, sharks endured. This incredible longevity speaks to the efficiency and resilience of sharks as a species. They've witnessed continents drift, mountain ranges rise and fall, and the very composition of Earth's atmosphere change. They were here before the dinosaurs. They witnessed their reign and their eventual demise, and they've continued to thrive long after. So, the next time you look at a majestic tree, remember that beneath its ancient branches, there's a lineage of ocean dwellers that stretches even further back in time. It's a powerful reminder of the deep history of our planet and the truly ancient wonders that still share it with us. Number 2, a day on Venus is longer than its year. When we think about planets, we usually have a pretty clear idea of what a day and a year mean. A day is how long it takes for a planet to spin once on its axis, and a year is how long it takes to orbit its star. Simple, right? Well, prepare to have your cosmic clock reset, because our closest planetary neighbor, Venus, completely defies this logic in a way that's truly mind-boggling. Imagine a planet where the sun rises in the west and sets in the east. A planet where a single sunrise and sunset cycle takes longer than it does for the entire planet to complete its journey around the sun. This isn't science fiction. This is Venus. Let's break it down. First, Venus's rotation. It spins incredibly slowly. So slowly that it takes a staggering 243 Earth days to complete just one rotation on its axis. To put that in perspective, if you were standing on Venus, you'd experience an incredibly long period of daylight, followed by an equally long period of darkness. And here's the kicker. Venus also rotates backwards compared to most other planets in our solar system. This is known as retrograde rotation. Now let's talk about its year. Venus is closer to the sun than Earth, so its orbital path is much shorter. It zips around the sun in just about 225 Earth days. Do you see the paradox? A single rotation of Venus, its day, takes 243 Earth days, while its entire orbit around the sun, its year, is only 225 Earth days. This means that a day on Venus is actually longer than its year. If you lived on Venus, you'd celebrate your birthday before the sun even had a chance to set from the previous sunrise. So, why is Venus such an oddball? Scientists aren't entirely sure, but the leading theories involve cataclysmic events in its distant past. One popular hypothesis suggests that Venus might have been struck by a massive object, like an asteroid or a protoplanet, early in its formation. This impact could have been powerful enough to literally flip the planet's rotation, slowing it down and reversing its direction. Another theory points to the sun's immense gravitational pull and the dense atmosphere of Venus, creating complex tidal forces over billions of years, gradually slowing its spin and eventually reversing it. Whatever the cause, this unique rotational period has profound implications for Venus's climate. The incredibly long days and nights contribute to its extreme temperatures, with the side facing the sun baking under intense heat and the night side slowly radiating heat away, though the thick atmosphere helps to distribute it somewhat, leading to relatively uniform, albeit scorching, temperatures across the entire planet. Venus stands as a fascinating anomaly in our solar system, a testament to the diverse and often counterintuitive physics that govern planetary bodies. It reminds us that even in our own cosmic backyard, there are still incredible mysteries waiting to be fully understood. Number 3, bananas are technically berries, but strawberries aren't. Today, we are about to uncover a botanical secret that sounds like a riddle, Bananas are technically berries, but strawberries aren't. Confused? You're not alone. Our everyday language for fruits often clashes with the precise definitions used by botanists. And this is one of the most deliciously perplexing examples. To understand this paradox, we need to put on our botanist hats. In the scientific world, a berry isn't just any small, soft fruit. A true botanical berry is defined by a very specific set of characteristics. Firstly, it's a fleshy fruit that develops from a single ovary of a single flower. Secondly, and crucially, it typically contains multiple seeds embedded within that fleshy pulp. Think about a grape, a blueberry, or even a tomato. They all fit this description perfectly. They have a soft outer skin, a fleshy middle, and multiple small seeds inside, all originating from one flower's ovary. Now, let's apply this definition to the humble banana. When you peel a banana, you find a soft, fleshy interior. If you look closely, especially in wild or less cultivated varieties, you'll see tiny black specks running down the center. These are the banana's seeds. While the bananas we typically eat are cultivated to be seedless or have infertile seeds, they still develop from a single flower with a single ovary, and they contain those rudimentary seeds. So, according to the strict rules of botany, the banana, with its fleshy pulp and internal seeds derived from a single ovary, is indeed a berry. It's a large, elongated berry, but a berry nonetheless. But what about the strawberry? It's literally got berry in its name, yet, botanically speaking, it's not a true berry. Why? Because a strawberry develops from a single flower that has multiple ovaries. Each of those tiny seeds on the outside of a strawberry isn't actually a seed. It's a tiny, individual fruit called an achene, and each achene contains a single seed. The fleshy, red part we eat isn't a ripened ovary at all. Instead, it's an enlarged receptacle, the part of the flower that holds the ovaries. Because the edible part isn't derived solely from the ovary, and because it has multiple distinct fruits, the achenes, on its surface, the strawberry is classified as an aggregate accessory fruit. This botanical distinction highlights how scientific classification often deviates from our everyday culinary language. It's a fascinating reminder that the natural world is full of surprises, and sometimes the most common things we encounter hold the most unexpected truths. So, the next time you're enjoying a fruit salad, remember that your banana might just be the most technically correct berry on your plate, while the strawberry is busy being something wonderfully unique. Number 4, you can start a fire with ice. Did you know that, contrary to the popular belief, you can actually start a fire with ice? It's a concept that seems to defy the very laws of nature. How could something that extinguishes flames be used to create them? The idea of harnessing a frozen block to ignite a spark feels like a trick from a fantasy novel. But believe it or not, this isn't fiction. With a bit of ingenuity and a grasp of basic physics, you absolutely can start a fire with ice. The secret lies not in the coldness of the ice, but in its ability to act as a lens. Just like a magnifying glass uses its curved glass surface to concentrate the sun's rays into a tiny, intensely hot point, a carefully shaped piece of ice can do the exact same thing. The goal is to focus enough solar energy onto a small piece of tinder, dry leaves, bark, or fine wood shavings, to raise its temperature to its ignition point. So, how do you actually do it? First, you need clear ice. Ice from a frozen lake, river, or even a solid block of ice made from boiled, bubble-free water works best. The clearer, the better, as air bubbles will scatter the light and prevent a strong focus. Once you have your ice, you need to shape it into a convex lens. You can do this by using your warm hands to melt and smooth the surface, or by gently rubbing it against a piece of fabric or even another piece of ice. The key is to create a rounded, bulging shape on at least one side, similar to the curve of a conventional magnifying lens. The larger and smoother the lens, the more effectively it will focus light. The science behind it is called refraction. When light passes from one medium to another, in this case from air into ice, and then from ice back into air, it bends. A convex shape causes these parallel light rays to converge at a single point, known as the focal point. At this focal point, the energy from the sunlight is concentrated, generating enough heat to ignite extremely dry and fine tinder. It's the same principle that allows light to focus through eyeglasses or a camera lens. Once your ice lens is shaped and polished, you simply hold it up to the sun, positioning it so that the concentrated beam of light falls directly onto your tinder. This isn't an instant process. It requires patience and a steady hand. You need the right kind of tinder, something that ignites easily, like char cloth, very fine dry grass, or birch bark shavings. As the tinder begins to smoke, gently blow on it to provide oxygen, encouraging the ember to grow into a flame. The ability to start a fire with ice isn't just a clever survival trick. It's a profound demonstration of understanding physics and adapting to extreme conditions. It showcases the ingenuity of the human mind and the surprising ways in which the elements can be manipulated. It's a powerful reminder that even in the most unlikely scenarios, knowledge and resourcefulness can turn the seemingly impossible into a very real and life-saving skill. Number 5, your stomach gets a new lining every few days. Biology holds many secrets and unexplained mysteries, especially that of our own, human biology. In this segment, we're talking about our own stomach, a churning, acidic powerhouse that breaks down everything we eat. But here's the mind-blowing part. The lining of our stomach, the very barrier protecting us from its ferocious contents, gets completely replaced every few days. Yes, you heard that correctly. Every 3 to 5 days, you essentially get a brand new stomach lining. Let's think about what your stomach actually does. It's not just a holding tank. It's a highly acidic chemical lab. To break down food, your stomach produces hydrochloric acid, the same stuff used in industrial processes to clean metals. This acid is incredibly potent, with a pH usually between 1.5 and 3.5. For context, battery acid has a pH of around 1.0. This formidable environment is essential for dissolving food and killing harmful bacteria, but it poses an enormous challenge. How does your stomach prevent itself from being digested by its own powerful secretions? The primary line of defense is a thick, protective layer of mucus. This mucus isn't just any slime. It's a specialized, gel-like substance rich in bicarbonate. Bicarbonate is alkaline, meaning it's the opposite of acid. It acts as a buffer, neutralizing any acid that tries to get too close to the stomach lining cells. This mucus forms a crucial physical and chemical barrier, shielding the delicate cells beneath from the corrosive effects of the hydrochloric acid and the digestive enzymes like pepsin. But even with this remarkable mucus shield, the environment is relentlessly harsh. Some acid and enzymes inevitably manage to penetrate the mucus, causing minor damage to the cells of the stomach lining. To combat this constant wear and tear, your stomach has developed an astonishingly efficient self-repair mechanism, incredibly rapid cell turnover. Specialized stem cells located deep within the stomach glands are constantly dividing, producing new epithelial cells at an astonishing rate. These fresh, healthy cells migrate upwards, replacing the older, damaged cells that are continuously sloughed off into the stomach cavity. This rapid regeneration ensures that any cells compromised by the acidic environment are quickly discarded and replaced before significant damage can accumulate. It's a nonstop, microscopic construction project, ensuring the integrity of the stomach wall is maintained at all times. This constant renewal is a vital process. If this sophisticated system of mucus protection and rapid cell replacement ever fails, even for a short period, the consequences can be severe. This breakdown is precisely what leads to the formation of stomach ulcers, where the acid begins to eat away at the stomach wall itself, causing pain and potential complications. So, the next time you're enjoying a meal, take a moment to appreciate the extraordinary biological ballet happening inside you. Your stomach isn't just a tough organ. It's a marvel of constant self-renewal, showcasing the body's incredible ability to adapt and protect itself from even its own powerful tools. It's a testament to the sophisticated and dynamic processes that keep us functioning day in and day out. And there you have it, folks. A whirlwind tour through some of the most mind-bending facts our world has to offer. From sharks silently witnessing the rise of forests to the botanical identity crisis of our favorite fruits, and the truly ingenious way ice can become a fire-starting tool. It's clear that reality is often stranger and far more fascinating than fiction. These aren't just isolated curiosities. They're reminders of the endless wonders waiting to be discovered right under our noses. So what was the most surprising fact for you today? Let me know in the comments below. And if you enjoyed peeling back the layers of these incredible truths, don't forget to give this video a thumbs up, share it with a friend who loves a good brain teaser, and make sure you're subscribed and have that notification bell rung, so you don't miss our next deep dive into the unexpected. Until next time, keep questioning, keep exploring, and keep being curious.